we can trace the present warming trend back at least 200 years, to the end of a very cold period in Earth's history. This cold spell is known to climatologists as the Little Ice Age.
Let it snow, let it snow.
After the Second World War, things changed. Consumer goods like refrigerators and washing machines and TVs and cars began to be mass-produced for an international market. Historians call this global explosion of industrial activity the post-war economic boom. So how does the industrial story compare with the temperature record? Since the mid-19th century, the Earth's temperature has risen by just over half a degree Celsius, just over half a degree Celsius, just over half a degree Celsius, just over half a degree Celsius. But this warming began long before cars and planes were even invented. What's more, most of the rise in temperature occurred before 1940, during a period when industrial production was relatively insignificant. After the Second World War, during the post-war economic boom, temperatures, in theory, should have shot up. But they didn't. They fell. Not for 1 or 2 years, but for 4 decades. In fact, paradoxically, it wasn't until the world economic recession in the 1970s that they stopped falling.
There is one relationship that is far more powerful than all the others.
The most impressive demonstration in Mr. Gore's movie is the big graph of carbon dioxide levels.
Here's what the temperature has been on our Earth. Now, one thing that kind of jumps out at you is, did they ever fit together?
My goodness, I knew that carbon dioxide's thought to amplify temperature increases, but this shows a clear cause and effect. For 600,000 years, when carbon rose, so did temperature. It suggests that carbon levels control temperature. But the real inconvenient truth is that carbon increases came after temperature rose, usually hundreds of years later.
Volcanoes produce more CO2 each year than all the factories and cars and planes and other sources of man-made carbon dioxide put together. More still comes from animals and bacteria, which produce about 150 gigatons of CO2 each year, compared to a mere 6.5 gigatons from humans. An even larger source of CO2 is dying vegetation, from falling leaves, for example, in the autumn. But the biggest source of CO2 by far is the oceans.
I wanted to ask Mr. Gore about that and other things, but he wouldn't agree to talk about this. Why should he, when he and others say,
the debate's over. The science is agreed upon.
The debate is over.
So here we're looking at the ice core record from Vostok, and in the red we see temperature going up from early time to later time at a very key interval when we came out of a glaciation. And we see the temperature going up, and then we see the CO2 coming up. CO2 lags behind that increase. It's got an 800-year lag. So temperature is leading CO2 by 800 years.
The common belief that carbon dioxide is driving climate change is at odds with much of the available scientific data. Data from weather balloons and satellites, from ice core surveys, and from the historical temperature records. But if CO2 isn't driving climate, what is? The Institute decided to compile a record of sunspots in the 20th century and compare it with the temperature record. What they found was an incredibly close correlation between what the sun was doing and changes in temperature on Earth. Solar activity, they found, rose sharply to 1940, fell back for 4 decades until the 1970s, and then rose again after that.
When we saw
the official journal of the American Geophysical Union, the blue line represents temperature change in the Arctic over the past 100 years. And here is the rise in carbon dioxide over the same period. The two are not obviously connected, but now look again at the temperature record, and at this red line, which depicts variations in solar activity over the past century as recorded independently by scientists from NASA and America's National Oceanic and Atmospheric Administration.
Then we went back in time
So Professor Friis Christiansen and his colleagues examined 400 years of astronomical records to compare sunspot activity against temperature variation. Once again, they found that variations in solar activity were intimately linked to temperature variation on Earth. It was the sun, it seemed, not carbon dioxide or anything else, that was driving changes in the climate. In a way, it's not surprising. The sun affects us directly, of course, when it sends down its heat. But we now know the sun also affects us indirectly through clouds. Clouds have a powerful cooling effect, but how are they formed? In the early 20th century, scientists discovered that the Earth was constantly being bombarded by subatomic particles. These particles, which they called cosmic rays, originated, it was believed, from exploding supernovae far beyond our solar system. When the particles coming down meet water vapor rising up from the sea, they form water droplets and make clouds. But when the sun is more active and the solar wind is strong, fewer particles get through and fewer clouds are formed. Just how powerful this effect was became clear only recently, when an astrophysicist, Professor Neir Shaviv, decided to compare his own record of cloud-forming cosmic rays with the temperature record created by a geologist, Professor Jan Weitzer, going back 600 million years. What they found was that when cosmic rays went up, the temperature went down. When cosmic rays went down, the temperature went up. Clouds and the Earth's climate were very closely linked. To see how close, you just flip the lines.
We just compare the graph, just put them one upon the other, and it was just amazing. Jan Weitzer looked at me and says, you know, we have very explosive data here.
I've never seen such vastly different records coming together so beautifully to show really what was happening over that long period of time.
The climate was controlled by the clouds. The clouds were controlled by cosmic rays. And the cosmic rays were controlled by the sun. It all came down to the sun.
That's pretty scary, Dr. Michael Kaufman, and I don't think SUVs have anything to do with the nuclear reactions in the center of the sun?
Not likely. It is very interesting that the solar radiation and the Earth's temperature are highly correlated. In fact, they can actually be almost on a daily coordination. We had a major solar eruption back in 1998 at the same time as we had El Nino, and we had a solar spike within a week, a temperature increase within a week of that event that peaked out within a few days, about a week or so, and this is global. This isn't just the United States or a local regional area. This was global. And the two combination, the El Nino and a solar spike in which we had a major solar eruption that was pointed right at Earth, actually changed the Earth's temperature right away. And if you go back into the 1700s, you can actually see the correlation between the Earth's temperature and the emissions of radiant energy by the sun.